Hello everyone and welcome back to the channel. In this video we're going to build a custom RV surge protector, which is not only going to protect the coach against surges but also against under and over voltage conditions, which are arguably worse for the equipment in your coach than a surge. Now the reason we're making our own is I was looking around for a new surge protector for the RV. I was doing a lot of research trying to figure out which one would offer the best protection for the best value. And all of the brand name surge protectors were coming up short in one category or another, and most of them did not actually protect against under and over voltage, which I've lost a couple of rooftop air conditioners to in the past. They were all priced in the $300 to $400 range, and I was thinking, well, if I can make one that's better around the same price, why wouldn't I? And so I decided to make my own. I'm going to show you in this video how I built it. Before we get into the actual build, I need to provide a quick disclaimer. This is not intended to scare you away from this project, but remind you that there are some risks involved and you should not ignore them. This project involves installing electrical components that operate at dangerous voltage and current levels. If you choose to follow the steps in this video, please be careful when connecting these items together. Double check that all the connections you've made are correct and ensure that power is off when working with any service equipment. And do not do this if you don't feel comfortable doing electrical work. You're responsible for any damage done to your equipment and/or any injuries incurred. So let's go ahead and get started on the build. First thing we're going to do is run through all of the components. So the first one here is the 𝐒𝐮𝐬𝐫 𝐂𝐡𝐚𝐧𝐧𝐞 whole home surge protector. This is meant to be installed on your home's main electrical panel. It has a withstand rating of 108 kiloamps, which is a little bit higher than most of the plug-and-play RV surge protectors on the market. They were all in the sub 100 range. So this will be providing the surge protection function for our custom unit. So on the front here, got a couple of indicator lights, and then you'll see it's got some number 10 stranded cable for connection. Next thing on the list here is the enclosure that we're gonna put all of these items into. So this is a outdoor rated plastic enclosure from Amazon. It's got some stainless steel latches and a hinge door. It's also got a spot to put a padlock on it if you did want to lock it down so that no one could open it up and change any of your settings. It also has a gasket around the inside of the door to keep the box weather tight inside. And this backing plate came with it as well for easy mounting, and then of course some mounting hardware. Next up we have the 𝐒𝐮𝐬𝐜𝐫𝐢𝐻𝐻 timer 120 volt under and over voltage relay. These guys are made to snap onto a DIN rail. As you can see there, it's got input and output terminals, input on the upper side and output on the bottom side. And these guys are 60 amp rated terminals, so they'll be perfect for our 50 amp electrical service. Here's the installation instructions. These are important. They tell you how to go ahead and adjust the relay settings. And then we just have another relay. We need two of these for the installation, one for each of the 120 volt legs that makes up our 50 amp electrical service for the coach. Next item is a DIN rail kit with some DIN mounted terminal blocks. These terminals are rated at 60 amps as well, so they will work perfectly for a 50 amp electrical service. I think there's 10 total terminal blocks for a total of 20 terminals. You can see they just kind of snap on and off of this DIN rail here, and this DIN rail is also compatible with the 2 relays that we bought. Next up, we have the receptacle and plug that will go at the input and output of our device, allowing you to plug into the power pedestal and then plug your coach's cabling into this surge protection unit. So that's the female 14-50R, and then here is the male 14-50P. The next item is kind of optional, but I figured since we were making our own unit, we may as well pull out all the stops. So this is a RV circuit checker or tester for 50 amp electrical services. So basically you plug this into the power pedestal and it lights up and tells you if the plug is wired correctly or if there's any open terminals, any issues that might occur when you are going to go plug your coach in. So I'm going to take this guy apart and use it inside of our housing as well. Next on the list, we have a couple of 1-inch waterproof cable glands, and these are basically going to allow the connection of our SO cable to this plastic enclosure. So there'll be one at the top of the box and one at the bottom of the box, and that's going to allow the SO cable to pass through and create a watertight connection. As you can see, they have a interior gasket that'll wrap around the SO cord, and then as you screw the nut back on, it kind of tightens down around it, and then another gasket and nut for the box side. This leads us to the SO cord itself. You're going to need about 3 feet of 6'4" SO cord cut in half, one for the top end of the box, one for the bottom end of the box. I recommend getting this by the foot at Home Depot. Also, you're going to need about 2 feet of number 6 or number 8 wire, and then about 3 feet or so of number 12 wire, and then some white, green, and red electrical tape to mark the wires appropriately. And lastly, we are going to need a cutting board. Now, I know that sounds super weird, but we're actually going to make a front for our case, and this cutting board is the perfect solution. It's a plastic non-conductive front panel. This will keep everything insulated for safety purposes. And then we will need a couple of miscellaneous items as well: some silicone sealant, a small piece of 3/4 inch plywood cut to fit inside the enclosure, some screws of various sizes, and some nylon spacers. And I'll link all of these items that I use for the build in the description below for you. Now we need to install everything into the enclosure. Unfortunately, the video I took of this part got corrupted, so I'm just going to show you the final wired up product. That way you can get a sense of how the enclosure was laid out and where the pieces and components were placed. So first we installed the SO cable glands at the top and bottom of the box. These were just kind of centered in both directions on those ends of the enclosure, and then installed with some silicone around the openings for extra waterproofing. Then we have a piece of 3/4 inch plywood mounted onto the back plate that came with the box. We needed to space these elements up a little bit so that they would flush out properly with our custom cutting board cover plate. I also had to cut a couple of notches into the plywood around where the cable glands were to make room for the incoming cable. You can kind of see it here in the picture. Next thing you need to do is cut down the DIN rail so that it is just the width of the inside of the enclosure. And then you could go ahead and attach that to the piece of plywood with a couple of screws, and then snap the relays and the terminals onto the DIN rail. And then next, I installed the 𝐒𝐮𝐬𝐜𝐫𝐢𝐛𝐞 SPD. Because of the height difference between the relays and the SPD, I placed some 1/4-inch nylon bushings between the SPD and the plywood to kind of lift it up so it would flush out better on our custom cover plate. And then finally, we need to make our custom cover plate. So go ahead and take your cutting board and cut it to the inside dimensions of the enclosure. Then dimension off of the inside edges of that enclosure and draw out those cutouts for the SPD and the 2 relays. I did this first with a scrap piece of 1/4-inch plywood so I could use that as a template, and then ultimately transferred those lines to the cutting board and cut out the opening in the actual cutting board. Then I took a router and removed some of the material from the backside of the cutting board around the SPD and where the LED lights would go. Next, we're going to go ahead and mark out our 4 holes for the LEDs of the circuit tester, just to the side of the SPD. And then we're also going to do 4 holes, 1 in each corner, for the mounting of the cover plate down to the plywood. I also glued together a few smaller bushings to make a larger bushing, which was the correct distance between the top of the plywood and the bottom side of the cutting board. And now let's get to the wiring. As I mentioned, we're going to take this guy apart here and use it within our box. See, there's a screw deep down in here. There's 2 more screws behind this. So as you can see, there's a small circuit board in here that's running the logic for these LEDs. That's the back side of the LEDs there. We're going to go ahead and push those diodes out from the front to the back. And then we're going to go ahead and cut the conductors off of these terminals, and we'll use a wire nut to connect them to some extensions in the box. Now let me show you how we're going to connect all of these components together. So this is the exploded parts and wiring diagram for this build. As you can see, all of the conductors are color-coded, and the line thickness is used to represent the wire gauge. We will start with the ground connections, starting on the input side of the unit and working toward the output side. So here on the input side, we're going to attach one of our SO cords, the green wire within that, to the ground pin of this plug. The ground pin is the circular pin for reference. Then we're going to take that and connect it to one of our terminal. Similarly, on the output side, we're going to take the other SO cord, connect it to the ground pin of the receptacle, and then run that wire through the box and to the opposite terminal block. Then we'll take the ground conductor from the 𝐒𝐮𝐬𝐜𝐫 SPD and connect it to the adjacent terminal block. And then we'll take a piece of number 12 wire about 10 inches long and connect that to the remaining terminal block, and that will be used for connection to the circuit tester. Next, we're going to connect the neutral conductors. Neutral is depicted as gray in this diagram, but will be white in practice. So again, starting on the input side, we'll connect the neutral wire to the neutral pin of the plug. Then this will get terminated on one of our terminal blocks. In an adjacent terminal block, we'll take a number 8 white wire and connect to the incoming neutral connection of the first relay, and then we'll jump that connection to the input neutral connection of the second relay. On the output side of the relays, we'll connect the neutral conductors back to our terminal blocks. Then for the receptacle side, we will connect the white wire from the SO cable to the neutral pin and bring that through the box and terminate on one of our terminal blocks. Then we'll take the neutral wire from the 𝐒𝐮𝐬𝐜𝐫 SPD and connect that to one of our terminal blocks. And then similarly, we'll connect another number 12 wire, about 10 inches long, to this terminal block for connection of the circuit tester. Now let's connect the line 1 conductors. So just like before, we're going to connect the red conductor in the SO cable to the line 1 conductor pin on the plug. And the other side of that conductor will connect to the L terminal of one of the relays. Next, connect the output side L terminal back to one of our terminal blocks. And then from a terminal block, we'll connect a SO cable red wire to the line 1 pin of the receptacle. Then we'll go ahead and connect the red wire of the 𝐒𝐮𝐬𝐜𝐫 SPD to the terminal, and then another number 12 10-inch cable to the circuit tester. Lastly, we'll do the line 2 connections. These will be just like the line 1 connections, but with a black conductor instead. So we'll take the black conductor of the SO cable, connect it to the line 2 pin, and then to the L terminal on the second relay. On the output side of the relay, another number 8 black wire to the terminal block, and then the other SO cable black wire will connect through to the line 2 pin of the receptacle. Then we'll take the black wire of the 𝐒𝐮𝐬𝐜 SPD and connect that into our terminal block, and then another short 10-inch piece of number 12 wire for connection to our circuit tester. Now, it's important to put these bridging pins into the terminal blocks. These are what connect the terminals to each other. And so you'll see here, most of them we're just connecting 2 terminal blocks, but in the case of the neutrals, we have 3 blocks connected. So I'm here in the storage unit where I keep the RV. I'm going to go ahead and plug in our surge protector. Very difficult with one hand. There we go. Now we see everything's turning on. We have the relay showing the voltage of each of the lines. And then we've got the circuit tester showing the status there. And then the 2 lights on the 𝐒𝐮𝐬𝐜 SPD indicating that the unit's protected. Now that we know that the unit's working properly, we'll go ahead and plug it into the coach. And there you go. Now the coach is powered. And the last thing I'll show you how to do is go through and set up the relays. To set up the relays, press and hold the set button until the display flashes. Then use the up and down arrows to set the values for that setting. Hit the set button again to lock it in. Repeat this for all the settings, and when you see the screen say end, hit set one more time, and that'll lock in your settings. I'll go ahead and post my relay settings in the description below if you'd like to reference them. And that's it. Now, we have used this unit a couple times at different parks, and it's worked pretty well. One park where we've lost a few air conditioners to undervoltage, the unit did in fact cut the power to the coach because of an undervoltage problem, and then restored it shortly after once the voltage was back in range. So overall, I'm pretty happy with the result. It was a fair bit of work to configure and build. The unit ended up costing just under $400, but I think it's a more robust system than the plug-and-play off-the-shelf solutions that are out there. Thanks for watching, and I hope you found this video insightful, and if you did, please give us a like and subscribe to the channel. We've got more RV electrical fixes and DIYs coming up in the near future that you're going to want to see.